The objective of this lesson is to be able to build models, draw representations, and write equations to represent problem situations in fraction division problems without remainders using the measurement interpretation. It's important for students to know that when whole numbers are divided by whole numbers, the quotient is smaller than the dividend and divisor. However, a whole number or a fraction divided by a fraction usually yields a quotient larger than the dividend and divisor. A pattern of division problems can demonstrate this is true. 8 divided by 8 equals 1. It's asking how many 8s are in 8. 1. 8 divided by 4 equals 2. 8 divided by 2 equals 4. 8 divided by 1 equals 8. Now let's do the fractions. 8 divided by 1/2 equals 16. 8 divided by 1/4 equals 32. 8 divided by 1/8 equals 64. Notice how the quotients get larger each time as the divisors get smaller. When the divisor in red is a whole number, the quotient in green gets smaller. But when the divisor is a fraction, the quotient gets larger. Now let's solve a problem by modeling with Cuisenaire rods. Parker's stride is 2/5 of a meter long. How many steps would Parker need to take to travel 6 meters? First, we need to choose a rod to represent 1 meter. The rod will have to be the same length as 5 smaller rods to represent 1/5 of a meter. Let's line up the 6 yellows and enough whites to make the same length as the yellows. It looks like 30 whites, so 6 equals 30/5. But wait, Parker's stride is 2/5 of a meter. Let's line up a red rod for every 2 white rods. The red rod represents the length of one of Parker's steps. The white rods are there to help show the relationship between the red and yellow rods. The number of red rods will be the answer to how many 2/5 are in 6 whole meters. 15 red rods is equal to 6 yellow rods. If Parker's stride is 2/5 of a meter, he will take 15 strides to walk 6 meters. We modeled the problem. Now we'll draw the representation. We could draw all of the rods or simply draw the yellow and red rods. What mathematical equation relates to this model and answers the question, how many steps the size of 2/5 of a meter are in 6 meters? Or simply, how many 2/5 are in 6? 6 divided by 2/5 equals A. This model also helps us visualize the multiplication equation, 15 times 2/5 equals 6. Let's look at a different way of modeling and recording our thinking. We will use graph paper. Dixie's stride is 3/4 of a meter long. How many steps would Dixie take to travel 6 meters? The question we will ask ourselves is, how many 3/4 are in 6? The blue rectangle will represent 4/4 or 1 whole meter. How many meters will we need? Yes, 6 meters or 24/4 meters. Then, what would be the value of the green square? Yes, 1/4 of a meter. There will need to be 3 green squares to represent 3/4 of a meter. It can be represented in different colors to help us see the sections of 3/4. There are 8 steps that Dixie needs to take to walk 6 meters. Another way to draw the modeling that was done is to mark off 6 meters, then color in each 3/4 meters in a different color. This drawing shows 3 different equations. 6 divided by 3/4 equals 8. 8 times 3/4 equals 6. And 24/4 divided by 3/4 equals 8. Let's fill in the worksheet. How many steps will it take Dixie? It will take Dixie 8 steps. The division equation is either 6 divided by 3/4 equals 8 or 24/4 divided by 3/4 equals 8. The multiplication equation is 8 times 3/4 equals 6. The objective in this lesson was to be able to build models, draw representations, and write equations to represent problem situations which include fraction division problems without remainders using the measurement interpretation. We met this objective by modeling, drawing, and writing equations. It's important to let students explain their work to you to make clear their understanding, which will reveal any mistakes in their thinking.